from a solid cylinder whose height is 2.4 centimeter and diameter has been given to us as 1.4. So remember, if I know the diameter, we'll know the radius, right? A conical cavity of the same height and same diameter is hollowed out. So remember, okay, this cylinder was solid at first, no hole was there, right? But what is the question saying? They're saying that they took out a cavity here like this in a shape of a cone, right? They have taken it out, which means remember that here now inside there's this the shape of a cone is inside here, right? So now let's go back to the question. They're asking us to find the total surface area of the remaining solid to the nearest centimeter square. So they'll find it will be curved surface area of the cylinder, right? The curved surface area plus, remember, like I told you, inside here the shape of a cone is already there, right? So it will be plus curved surface area of the cone, right, plus the base area of the cylinder, right? Then that is how we'll get the total surface area of the remaining solid. Okay, so now have a look here. Height given to us, right? They've given us the diameter also. And how do I find the radius? Divided by 2. So I'll have here 0.7. Now when you look at the curved surface area of a cone, what is the formula? Pi r L, right? This is the slant height. So you'll notice here that I don't know the slant height. Okay, so let us try to find that first. So from here now, slant height of the cone, already know the formula. L equals root over h square plus r square, right? Remember, we're trying to find the slant height. Okay, so h we already know 2.4, and what about the radius? Radius is 0.7. So if you find the square of 2.4 square, we're going to get 5.76. Same thing, 0.7 square will get 0.49, right? So when you add these two, we're going to get 6.25, which is a square root of 2.5. All right, so now we know the slant height equals 2.5 centimeter, right? Now we have all the information. We just have to put it directly in the try to find the total surface area. Okay, so once again, remember the outer surface area of the cylinder, this is the outer, right, plus the curved surface area of the cone, because remember I told you that inside here there is a cone. Now I have to know the curved surface area of the cone plus area of the cylindrical base. Remember, this is still covered. Okay, so we have to find the area of the cylindrical base too. So what is the formula? So if you look at for a cylinder, the curved surface area, the outer surface area is pi r h, right? What about the curved surface of the cone? Pi r L. And area of the cylindrical base, like I said, the cylindrical base is a circle, right? So area of the circle is pi r square. Once we're done with that, when you look at the question, when you look at the formula here, you can see that what pi r is common. That's why I've taken out pi r here. Clear? So now once I've taken out pi r from here, what is left? 2 and h is left, right? I've taken out pi r here. What is left? L. Here pi r already taken out, but you can say r squared. There are 2 r, right? So 1 r will still be left. Okay, so now once we're done with it, we just have to put the values in order to find it. Okay, so pi, the value is 22.7, radius we know 0.7, height is 2.4, slant height we just got it 2.5, and the radius is 0.7. all right, so now I can divide this 7 to 7, 0.1, right? And when you multiply these two, we're going to get 4.8, and then we'll be left with 2.5 plus 0.7. So when you add all these, we're going to get 8 here. Okay, so now we're going to what? When you multiply this two, right, 22 into 0.1, we're going to get 2.2, right? Now, like I said, when you add all these, we're going to get 8. So when you multiply these two, we're going to get 17.6. The question told us to the nearest, right? So 17.6 is almost close to 18. That's what we're taking here, 18 centimeter square. Alright, the last question. A wooden article was made by scooping out a hemisphere from each end of a solid cylinder as shown, right? If the height of the cylinder is 10 centimeter and its base radius is 3.5, find the total surface area of the article. So remember, actually this was a solid cylinder. Okay, so what did they do? The question is saying that they scoop out, right? They have taken out 2 hemispheres from here, one at the top, one at the bottom, as you can see, right? And they're asking us to find the total surface area. So total surface area, how do you find? Curved surface area of the outer curved surface area of the cylinder plus, like I said, now because see, they've taken out this hemisphere, which means inside here there's a hemispherical cavity, right? Both top and at the bottom. Okay, so the total surface area will be curved surface area of the cylinder plus curved surface area of the top plus the curved surface area of the bottom hemisphere. So when we add all this, we'll get the total surface area of the remaining article. Okay, so height given, radius given, nothing to do. Total surface area of the article, like I said, the outer surface area of the cylinder, right? Outer surface area plus, you can see that inside here 2, the shape the shape of two hemisphere inside is already there here, right? The cavity, okay, it's in the shape of a hemisphere, one at the top, one at the bottom. That is why 2 times, right, curved surface area of the hemisphere. So now we just have to put the values straight away, okay? So the outer surface area of the cylinder, what is the formula again? Twice pi r h. This 2 is here because there are two hemispheres. Then curved surface area of the hemisphere, what is the formula? Twice pi r square, right? So now if once we are done with that, we have to start taking, let's start by taking the common, right? So you can see twice pi r is common, I can take twice pi r common, right? So from the first, if I take out twice pi r common, only h is left, right? Now here this 2 is left, and you can see here that I've already taken out twice pi r, but r square, which means 1 r is still left, okay? That is why you can see there h plus 2 r, right? So now once we're done with that, we just have to start simplifying, right? Pi is 2 by 7, radius 2.5, height given 10, then 2 into radius is 3.5, right? Then you can divide 7 is 7, 7 into 0.5, alright? These 10, when you multiply these two, we're going to get 17, right? This is 17. So nothing to do, just multiply 2 into 22 into 0.5 into 17, then we'll get the total surface area of the remaining article to be equal to 374 centimeter square.